Hi everyone, welcome to the first video about for A-level chemistry. And at the point that I'm recording this right now, is relatively close to the A-level. Should be around 1 to 1.5 months away from the A-level. And honestly, I don't really know which um, chapter of chem to be in at. Yeah, I wanted to start with Mo, but I realized that by now at A-level, you guys should be more or less quite decent at whole concept already. Hence, I decided to start off with organic chemistry about enantiomers. Yeah, as I'm aware that some of you may struggle to do it. Okay, so let's get started. So today I'll be going through the very basic definition of what is enantiomers and how do you guys draw it and how do you guys identify. Yeah, so so this is the definition that I found, yeah, on the web, and I'll leave a specific definition to your school, and I don't want to confuse you guys because different schools may use slightly different terms. Yeah, so enantiomers are pair of molecules that, let's really take, sorry, in two forms. They are mirror image each of one another but cannot be superimposed on one another. So this definition of superimposed here is usually given. The tutors usually explain by giving the analogy of the left hand, the right hand. Ignore my bad drawing. So tutor usually that say the two hands are the same, but when you guys put the right hand over the left hand, you guys will get a different, because we're gonna get the same shape. So the forefinger would match up like that, but then the thumb would be opposite. So they are basically what they are saying is that although the two hands are the same, but when you put them on top of one another, the thumb part won't match up. And honestly, I find this example quite useless. Yeah, so I will be giving you guys some analogy that I use myself, and in fact, I believe going straight to the chem and the structure is more useful. Okay, so now let me draw a very simple and random structure. So let me say C, H, uh, sorry, CH3, H3C, then I draw wedge. Let me just use chlorine and dash bromine. So let's say this structure here, okay, let's just show this nicely here. Okay, so lower the thickness a bit. Okay, and then now I have a mirror plane. It's a mirror. Okay, I know some school may be quite specific. They want you to write down the word mirror here, like mirror plane or like reflection plane, yeah, whatever it is. Yeah, do whatever your school prefers. Yeah. So when you guys flip this, when you guys flip this structure over, you guys will get something like this. So see the H when you guys flip over, like that, and then chlorine flip over should be like that. Chlorine, tak, bromine, CH3. So you guys literally flip it about the mirror plane. Think about your math. So you guys are flipping it on the y-axis. Yeah. And what the superimposable means? So it means that if you guys put this molecule right here on top of this, okay, let's just label them A and B. So if you guys put A and B directly on top of each other, you guys will not be getting back the same molecule. So doing this requires some visualization. And so as you guys can see, for A, CH3 is on the left, but B, CH3 is on the right. So to superimpose them on top of each other, to stack both of them on top of each other, you guys have to rotate B. So let me do the rotation for you guys. So let me use green pen. So to flip CH3 here to the left, so H3C, carbon's the same, hydrogen is the same. Okay, but how about chlorine and bromine? So now chlorine is pointing out of the plane, right? But when you guys turn it 180 to the back, chlorine will be at the back instead. So the dash is chlorine. For bromine that's facing the back, when you guys turn it 180 to the it should go to the front. And is this the same as A? It's not, right? Because in A, the one that's coming out is chlorine, but the one that's facing the back is bromine. So can you guys see a difference? In B, bromine is go to the back, chlorine, sorry, in B, bromine is coming out, chlorine is going back, but in A, bromine is going back and chlorine is coming out. So if you guys cannot get it, look at the wedge and dash here. Here, chlorine is the wedge. Here, chlorine is a dash. Here, bromine is a dash. Here, bromine is a wedge. And CH3 and H are exactly the same. Okay, so actually, I don't like to draw enantiomers like this. I genuinely don't, because you guys have to like flip, visualize, and do all this spinny thing. So there's actually another way of doing this. So let me just call this. Let me zoom this out, and let me just call this the first method. So this is the first method drawing enantiomers. So what about the second method? So the method I actually prefer is that, let me just draw back the same molecule. So you guys have sorry, let me switch to black. Okay, so let's say that I have the same molecule again, CH, CO, Br. I don't like to draw the aeroplane. What I do is I simply keep CH, H3, C, and I keep the wedge and dash the same. So you see, here's a wedge, here's a dash. I keep it the same here as well. I keep it the same. So I draw a CL, I draw the wedge here, and I draw the dash here. But what I do this time is that instead of mirroring it, I swap the atom around. So here chlorine, right, is on top. I bring it down. Oh, sorry. Let me erase. So I bring the chlorine from on top, I bring it down. So chlorine will be here. And bromine is below, right? I bring it up. So bromine. And from here, your CH3, your H3C and CH3, they're already matching up. On the left, hydrogen is on top. So now you guys can see clearly, you guys can see very clearly that A and B are two different molecules that are non-superimposed on each other, because chlorine, the position of chlorine is swapped and position of bromine is swapped. So I prefer this second method. So I actually prefer this. How should I do this? I do it like that. I prefer this second method. Yes, so unless the question asks for a specific mirror plane, if they just ask to draw the enantiomers, yeah, feel free to use this second method, and I really believe that this is much easier to see. But I just a word of precaution is that some people, they mix up between the two methods. What they do is they flip and they swap the atom. By doing that, you are actually cancelling out the mirror image. So let me show you what I mean. So let's say let's draw the same molecule. Bear with me. Okay, it's in blue, but doesn't matter. So let's say I have this, right? Then they flip over. Okay, and yeah, you see in the first method, the chlorine get flipped, the bromine get flipped. But after it's flipped over, some people will flip chlorine, bromine, like as in this method. So they flip it around like that. Oh, sorry. They select my marker, they flip it like that. And this is actually wrong. Because if you guys mirror it and then you flip them, these two, one more, you guys will get back the same molecule. So this is actually the same as you guys can get back. Hey, you guys get back the same. Yeah, you guys get the same thing. Yeah, so please be very careful when you guys draw. Yeah, so I will end this video right here. This is a very basic introduction to enantiomers, and there are a lot more things to uh, go through for stereoisomers. Yeah, such as your cis trans, your diastereomers, and I and there are a lot of things that are not in H2 syllabus, but a lot of school covers extra. And please let me know if you guys want to go through it as well. Yeah, so I will end this video here today, and I hope that